Hello, lovelies. How are you? So, this week we are going to finish our chapter, which is volume. And yeah, so let's start. So, these are the objectives that we're going to cover in this lecture. Starting with the volume of a liquid. So we already defined a volume being, you guys remember, being the space that is occupied by a certain object. Now we're gonna get to the volume of a liquid, which is basically the same, the space that is occupied by this liquid. But how can we actually measure it? Like, how can we find the volume of a liquid? Let's click on this simulation and go to the next slide. Okay, so this page will open up. You press on this little triangle and there you go. This is the page that we're gonna work with. So yeah, I have this cylinder. Okay, so we know that the volume of a liquid, now we know that it is the space that is occupied by a liquid. All right, so where should I put this liquid? How can I measure this space? I can measure it using a graduated cylinder. So it is a cylinder, but it has graduations on it. You can see the numbers. These are called graduations. Okay, so this is a graduated cylinder and it measures the volume in milliliters. You can see the milliliters, the unit right here. So I'm gonna pour some water inside this graduated cylinder. Okay, so I'm gonna press it and pour some water up until, let's see here. All right, now that I finished pouring water, okay, I'm gonna put it right back. I need to read this volume. How can I read it? Where should I place my eye? For me to read it, I need to place my eye at the same level as the water inside this graduated cylinder. Okay, I shouldn't put my eye right here and I shouldn't be looking from the bottom and not from the top. It should be placed on the same level. All right, and this is how we measure the volume of a liquid. Now, the volume of a liquid, we said it is the space it occupies in its container, like how much space it actually takes in this container. Okay, so the volume of a liquid can be measured by means of a graduated cylinder, just like this one. So we place the liquid inside the cylinder and we simply read the value that we get. But where should we place our eye? We should place our eye where? Facing the at the same level of the liquid. But where exactly? You guys can see that it is maybe a little bit like a curve. Where should I place my eye? On the top of the curve or on the bottom of the curve? The eyes should be placed on the lowest part of this concave surface of this curve. So the lowest part of the curve, it gives me the exact value of the volume. And this is where we should place our eyes. So you can see a graduated cylinder. It has long lines drawn on it, which are called graduations, and short ones that are called divisions. All right. So to read the indication correctly, to read the volume correctly, we must know the volume that corresponds to each division between two consecutive graduations. What does that mean? Okay, so it means I know that this represents 10 milliliters, all right? And I know that this line represents 20 milliliters. But let's say I want to find how much does this line, how much does it represent? It's not 20 and it's not 30. The only way for me to find out is by finding the amount, the volume that is represented by each division. All right, so if this is 20, this is 21, this is 22, this is 23, and this is 24 milliliters. So each division, it represents 1 milliliter. Now, this is not the case in all graduated cylinders. we will have an exercise where I will explain this more, all right? But throughout this lecture today, all the graduated cylinders that you guys will see, they are all similar to this one, where each division will represent only 1 milliliter. All right? Now, I will be talking about the shape and the volume of a liquid. Like, uh, does the volume depend on the shape of the container that the liquid is in, or it does not depend on that? Let's find out using this simulation. Okay, so welcome to my lab. You can see that I have taken out three different containers. The first one is the graduated cylinder, the second one is a beaker, and the third one is also a glass container. All right, and all of them you can see they are all graduated. So I will be filling the graduated cylinder up until 100 milliliters, okay, so till the top, and we'll take it from there. So let's fill it first. So I'm filling it up to 100. Um, Okay, so that's 100. Now, what I will be doing, so you can see that the volume of the liquid that I have poured into this container is 100 milliliters. So if you placed your eye right here, you'll be seeing 100 milliliters. Now, what I will do is that I will be pouring this liquid, this water into the beaker and see how much the volume will become. So the volume in the beaker, you can see it, it is also 100 milliliters. Let's see inside this container. It is also 100 milliliters. All right, so what can we deduce? We can deduce that a liquid has a definite volume. It means that the volume of a liquid, it does not depend on the shape of the container. So I can put the same amount of liquid in three different containers and still get the same exact volume. All right, so it has a definite volume. Now we will know the difference between volume and capacity by defining capacity. So the capacity of a container, it is simply the volume of liquid it can contain when full. Let's say you can bring any water bottle and you can read on it the volume, right? We said, like you guys read last time, 500 milliliters or 1 liter, right? You read it before. So, what are these exactly? These represent also the capacity of this water bottle. This is the maximum volume that it can contain. So when you fill an empty water bottle, when you fill it, okay, then this is called the capacity of this water bottle. This is the maximum volume that it can contain. All right? So this is the capacity. It is simply the volume of the liquid that it can contain when full. Now you guys can open your books if you'd like, page 26, and let's work on the book a little bit. So we're going to get to know how we find the volume of a solid. All right, so first of all, it says pour some water in a graduated cylinder. So we poured some water in a graduated cylinder. And what is the volume of the water in the graduated cylinder? So we need to place our eyes right here and go and look at the bottom of the curve. You can see that the bottom is at not at 30, but one division lower than 30, which is 29. So this is 29 milliliters. How should the eye be placed to accurately read the volume of water? We said it, but we haven't wrote it. So the eye should be positioned on the lowest side of the concave surface or of the curved surface. All right, so on the lowest side of the curved surface. This is how we read the volume of a liquid. Now, they said introduce slowly the piece of modeling clay into the graduated cylinder. So I bring a piece of clay and I put it into this graduated cylinder. What will happen to the water? It will rise, and you can actually try that. Okay, you can put some water in a cup and put any type of solid inside this water cup, and you would see that the water will rise. All right, so what is the new volume reading in the graduated cylinder? So you put your eyes right here and you look at the lowest side of the curve that we have. So it is 39 because it's not 40, it's one division lower. So it's 39 milliliters. And now they say, deduce the volume of the piece of the modeling clay. So if V1, which is the volume of water, it was 29 milliliters, and V2, which is the volume of the water and the modeling clay, it is 39 milliliters. What would be the volume of the modeling clay? So what is the volume of the piece of clay? It is the subtraction of these two. So it is V2 minus V1. All right, which is 39 milliliters minus 29 milliliters equals 10 milliliters. And now we are able to find the volume of a solid. Now they are saying, take this piece of clay outside and change its shape. Okay, the same piece of clay, but you can play with it. You can make it into any shape you like. So you simply change its shape and then put it back. All right, so write down the reading in the graduated cylinder. What do you guys think? The reading, will it differ or will it stay the same? The clay, the piece of clay, I only changed its shape. All right, I didn't add more clay to it, or I didn't remove some clay from it. Okay, I only changed the shape. So the reading, it will not change. It will remain 39 milliliters. And then the volume of the piece of the modeling clay, it will not change. I'm just changing its shape. All right, I'm not I'm not doing anything to it. I'm just changing its shape, so it will remain 10 milliliters. Then it says, did the volume of the modeling clay piece change? What do you guys think? So if it was 10 milliliters and now it is still 10 milliliters, so no, it did not change. What can you conclude? That the volume of the solid, it does not depend on its shape. So you guys can bring a piece of modeling clay, shape it into a heart, shape it into a circle, shape it into a square. All right? If I'm working with the same piece of modeling clay, then all of these shapes, okay, all of them will have the same volume because the volume of a solid, it does not depend on its shape. Now, let's just summarize how we can actually find the volume of a solid. How can we find it? The volume of a liquid, it's really simple. Just pour the liquid, read the value, and that's it. But the volume of a solid, I can put the modeling clay right here or a bowl or any solid and simply read. All right, it doesn't work. So I have to pour some water and then find V1 and then introduce the solid and then find V2, which is the volume of the water and the solid. And how can I find the volume of the solid? It's V2 minus V1. Now let's go to this simulation so that we can have a little experiment. Okay, so now I need to find the volume of this marble. All right, so how can I find the volume of the marble? I cannot simply place it in the graduated cylinder and just read the value. It doesn't work like that. So how can I find the volume of this little marble? I can take out this graduated cylinder and pour some water in it. Okay, so I will pour water up until 20 milliliters. Okay, so that's 20. All right, so I can write it down. So I have V1 equals to 20 milliliters. Perfect. Now, What I will do is that I will be introducing this marble into this graduated cylinder. You can see that the water rised a little bit, and if you look at it, you would see it is at 21 milliliters. Okay, one division up. So it is V2. It's equal to 21 milliliters. Guys, can you now find the volume of the marble? Yes, it is V2 minus V1, which is 21 milliliters minus 20 milliliters, and that is 1 milliliter. And this is how we find the volume of a solid. There is a little note that says the solid should be insoluble in the liquid being used. What do you mean by insoluble? It means that this solid that I am actually introducing into a liquid, it must not dissolve into the liquid. Who can give me some solubles solids? Like salt, sugar, right? These solids, okay, they are powdered solids and they do dissolve in water. So I cannot find the volume of these solids using this method. All right, guys? So that's it. This is the note. So what we need to know is that the volume of a solid does not depend on the shape of that solid. I can change the shape and it will still have the same volume. So we can say a solid has a definite volume. All right? Guys, what if this solid that we're talking about has some particular geometric shape? Like, what if it is a rectangular prism? It's like a rectangle but in 3D. What if it is a cube? Do I need to bring a graduated cylinder, fill it in with water, and then introduce that solid and read the new value and then subtract for me to find the volume of a solid? No, it's much simpler than that. So for me to find the volume of a solid of a particular geometric shape, such as a rectangular prism, we can simply apply a formula. Okay, so let's look at this rectangular prism. Why does it called rectangular prism? You guys see it is a rectangle. Okay, so it is a rectangle, but it is in 3D. It has a certain thickness. All right, just like your books, you can look at your book. You can see that your book is a rectangular prism. All right, it has a certain thickness. So usually it has a length, A, you can see the length of it. You have a width, B, you can see the width of it, and you have a height to it, right? Which is C. So we have three different values. So for me to find the volume of this rectangular prism, it is simply A times B times C. So I multiply A by B and then by C. Let's have an example. So we have this rectangular prism right here with three different values for this is A, right? This is B, and this is C. How can I find the volume? Volume equals A times B times C. So it is 9.4 meters times 6.6 meters times 2.5 meters. And using your calculator, you would get 155.1. Now, what do you think, guys, is the unit here? I'm multiplying meter times meter times meter. So it's meter cube or cubic meter. All right? So this is how we find the volume of a rectangular prism. Now we need to find the volume of a cube. So a cube, it also has a length, a width, and a height. All right, but there's something like special about a cube is that the length, the width, and the height are all the same. So all the sides are equal in a cube. So for me to find the volume, I can do it. V equals A times B times C. But in this case, A, B, and C, they are the same. So I call them all A. So the volume of a cube is A multiplied by A and multiplied by another A. Let's have this example. So for me to find the volume of this cube, the formula is A times A times A. So what is the side of the cube? Guys, you know that there is no need for them to give me the other two sides. As long as they say this is a cube, they only need to give me one side, and I know that this is A, and I can use it to find the volume. So it's 4 meters times 4 meters times 4 meters. So the answer is 64, and the unit is meter cube or cubic meter. And that is it. We're done with the entire chapter. I hope this is clear. If you have any questions, we will be, going through them again in the live session and solving some exercises. I'll see you guys. Take care and bye-bye.